Yeah, welcome back. So this is the video especially towards explaining the K map. What is K map? That is Karnaugh map and how it is written for both half subtractor and full subtractor. Similarly, you can derive the K map for the half adder and the full adder. So for half subtractor, the K map is written in this way. So we have A and B. So we have 0 and 1 as the input, and for B we have 0 and 1 as the input. So now by seeing this truth table, this is called the truth table. So by seeing the truth table, you have to map out wherever there is 1. For now, like now we are writing the K map for this difference only. So in the difference, like how I explained, so what is the difference? Difference is basically the XOR of these two. So 0 XOR 1 is 1, 1 XOR 0 is 1. So for 1 1 it is 0, for 0 0 it is 0. Now for this difference we are writing the K map. So for this 0 and 1, for 1 0 it is 1. So that's why we write 1 only in these two cases. Now how do we write this equation for difference? So for difference, we have for 0 1 we have 1. So how we are writing? A naught B, then A B naught. So A B naught. So the OR of these two is what? The difference. So this difference is nothing but, what is this expression? You can see A naught B plus A B naught. This is a kind of XOR expression, right? So this difference you can also write as this A XOR B XOR this difference equation you can write as A XOR B. Okay, so this is the expression for difference, A XOR B, after simplifying this. Whereas for borrow, you see how we wrote the borrow when the first input was smaller than the second input. Only in that case it will be 1. So here in this case only A is smaller than B, so here it was 1. Now for borrow, how do we write the K map? So for borrow, the K map is that, you again draw this same table. You copy this for borrow and you paste it here. Okay, just a second. Let me put you this. So for borrow we have only for 0 1 we have 1. So for 0 1 we have 1. So this will be 0. So only in the 0 1 case we have 1. So what would be the expression for borrow? It is nothing but A naught B. So A naught B is the expression for borrow. So this is how this expression got from this K map. So A naught B. Difference is A XOR B. Borrow is A naught B. It was simple. Now we'll come to the full subtractor. So the K map for full subtractor will be, first we take the truth table. In the truth table we have A, B, B in, has 3 inputs. So how did we get the difference? So the difference was basically, it is the whenever we have to do XOR, so it is the result of that. 0 XOR 0 XOR 0 is 0. 0 XOR 0 is 0. 0 XOR 1 is 1. 0 XOR 1 is 1. 1 XOR 0 is 1. So it is difference is basically the XOR of these 3 inputs. So for this difference, for this column, we make the K map. So for 0 0, how do we make the K map? So first we will take one of the inputs at this side, which is A, and we take 2 inputs at this side, B, B in. Okay. So for A we have only 2 possible combinations, 0 1, whereas for 2 inputs we have 4 different combinations, 0 0, 0 1. Instead of writing 1 0 here, you write 1 1. So 1 1 and then 1 0. So wherever there is 1, so for 0 0 1 we have 1 here. So 0 0 1 we have 1. Okay. Then for 0 1 0 we have 1. So 0 1 0 we have 1. Okay. Then we have for 1 0 0 we have 1. For 1 0 0 we have 1. So 1 here. Then we have for 1 1 1 we have 1 here. 1 1 1 1 here. So for these 4 we have 1. then we take the equation for this. So you know, a naught b in, then plus a naught b in naught, okay, here, sorry, this one, then a naught, sorry, a b naught b in naught, this one, then a b in, okay. So after you simplify, you will get expression as something like this: a XOR b in. So this is the expression for difference. Whereas for borrow, what you have to do, borrow is nothing but it is the same as the borrow for the half subtractor. Whenever a is smaller than b, so here it is equal, so directly we can put as 0, as borrow is also 0. Here it is equal, but we took a borrow over here, so b out will also be 1. In these two cases, it is smaller, a is smaller than b, so here it is guaranteed that b out will be 1. In these two cases, a is greater than b at least, so irrespective of the borrow in, we can say that borrow out is 0 because a is greater than b. In these two cases, in the first case, a is equal to b, so we have to check whenever there is equality in ones, we have to check the borrow in. Borrow in is 0, so it doesn't matter, so borrow out will be 0 because it is equal. If here a was 0, then we could write b out as 1. So as a and b both are 1, so here it is 0. Here both are equal, and alongside with that we have borrow in as 1. So borrow in, so a is not smaller to b, that is one thing, but we are taking a borrow here, so that's why borrow out will be 1. So the first thing here, we are taking the borrow, so for this it will be 1. Here in these two cases, a is smaller than b, without seeing the borrow in, we can say that borrow out is 1. In this case, both were equal, but we are taking a borrow here, so borrow out will be 1. So now we write the equation for borrow out. When we write the equation for borrow out, we will draw a k-map, and when we draw a k-map, we will get for these 4, 1, 2, 3, 4. So the equation will be a naught b in, a naught b in naught, a naught b in, and then a b in. When you simplify, this is the expression, just what I told you for borrow. Okay, so I think after simplification you will get the smaller equation for borrow out as well. I think the last expression that you will get for borrow out, so that would be this: a XOR b complement and b in plus a XOR b. Okay, so this is the latest expression you will get after simplifying the borrow. Okay, we have the expression for borrow out, we have the expression for difference. So I hope now you understood how we draw the k-map and how we put the numbers in the k-map using the truth table.